This is the screencast for section 4.1, example 4. We're going to design a running track. I don't know if any of you have run track or have seen track run or have seen the Olympics one day, I don't know, but on a lot of races, the runners start out at different lengths, and that's because they're in different lanes and the outside lanes have to run farther. So they get a head start, if you will, but at the end of the race, they all end up running the same length because they have to run outside the longer piece but get a shorter distance, get a closer starting point. So the running lanes at the Emory Sears track at Bluffton College are 1 meter wide. The inside radius of lane 1 is 33 meters, and the inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 1 around one turn? So I have two different arcs that I'm working with, the inside arc of lane 1 and then the outside arc of lane 2. So I'm looking at what is the difference between the two. So I'm going to take arc length 2 minus arc length 1. And since that is what I am looking for, I have an expression for each of those. Arc length 2 is going to be, let's see, arc length in general is r times theta. Well, the radius of lane 2 is 34 meters, and its theta, its angle, is half of a circle, so that's just pi radians. Now arc length 1, its radius is 33 meters. Its arc length is also pi radians. So if I have 34 pi minus 33 pi, I don't even need a calculator for that one. That is pi meters, or 3.14 meters longer. So arc length 2, or lane 2, just around this curve is going to be 3.14 meters longer than the other one. The Now Try problem number 37 says that it takes 10 identical pieces to form a circular track for a pair of toy racing cars. This problem always reminds me of when my brother and I almost burnt down our house because of his old race car set. Toys in the good old days, those toys that could actually light your house on fire. Thank goodness for linoleum tile that just melted and a good sense of smell. Alright, we caught it in time. Everybody was cool. If the inside arc of each piece is 3.4 inches shorter than the outside arc, what is the width of the track? Well, I'm going to draw the track first. So at this point, we know that the inside arc of each piece is 3.4 inches shorter than the outside arc. So we'll call that arc 2 minus arc 1 is 3.4. I don't know exactly how I'm going to use that yet, but we'll go from there. We are looking for the width of the track, so if I call this outside radius 2, kind of like I did in the last problem, and then the inside radius, well, which would be here, the inside radius would be radius 1, I am trying to find radius 2 minus radius 1. Well, arc length formula says that S equals R times theta. If I solve for R, I can use R2 in an expression on the other side of the equal sign here. So R is S over theta. So R2 is going to be S2 over theta, and then R1 is going to be S1 over theta. Now, there are 10 pieces of track here that go around a 2 pi circle. 2 pi radian circle. So 2 pi over 10, let's see, theta is going to equal 2 pi over 10, which is pi over 5. So R2 minus R1 is, well, I can combine this common denominator here, so that would be S2 minus S1 all over theta, which we said was pi over 5. And then that would be, oh look, that's where we can use our S2 minus S1, so that's 3.4. So R2 minus R1, which is what we're looking for, the difference in the two radiuses, the width of the track, is going to be 3.4 over pi over 5. And in my calculator, I get that that is about 5.41 inches.